Good morning, everybody. We're gonna go back to the little remote days. Sorry I can't be with you today. I'm bringing Mackenzie to college. I'm going to do a little teaching on the next two lessons in the packets that I gave you, and then you're gonna spend some time working on those problems. When I say a section at the beginning of those little packets, there's a title, like the first title was Real Numbers, and then there was like 3 pages with problems all in different orders. That's what you need to finish for each packet. So by Friday, you should have the first 3 sections completely done. All right, so the second section is called Solving Equations, and that is what we are going to work on today. So I believe that you guys this will be an easy section because I'm pretty sure that you are great at solving equations, but we're just going to briefly go over the steps of what we would do to solve a one variable with just a x in it equation. All right, so the first step I would do is to combine like terms, make this as simple as possible. So here I could combine the 9x and the minus 4x to get 5x. Here I can I can distribute, so I get 3x minus 9. Now to solve the equation, I want to get the variables on one side and the numbers on the other side. So what I'm going to do first is I'm going to subtract 3x from both sides. So I get 2x plus 5 equals negative 9. And then I'm going to get the numbers on this side, negative 9 minus 5 on each side. So I get 2x equals negative 14. Divide by 2, x equals negative 7. It's always a good idea to check your answers. We will be doing some equations that you make some assumptions here when we get to the bottom that this number doesn't always work. So let's just get into the habit of doing that. I'm going to plug that back into my simplified equation here and see if it works. So 5 times a negative 7 is negative 35, plus 5 is negative 30 on this side. 3 times negative 7 is negative 21, minus 9 is negative 30 on this side. So yes, that number works. A couple of features of solving equations that we will be using this year is formulas. Sometimes we want to take a formula and solve for a different variable. When we're talking about equations that have definitions related to them, they're called literal equations. So for example, d equals r times t. It literally is a definition of distance. Distance is rate times time. Sometimes though we're given the distance and we're given the time and we want to solve for rate. So you might have an example where you want to change your formula and solve it for a particular variable. So in this case, if I wanted to solve for r, that means I want to get r all by itself. So I can divide both sides here by t. So I get d over t equals r. All right, that's what it means to solve a literal equation. A couple of special kind of equations that I wanted to go over with you are absolute value equations and equations with fractions. So if I have this equation, we know that if this thing inside here equals 3, then the absolute value of that would be 3, and we'd have a correct answer. But also, if the expression inside here equals negative 3, when we take the absolute value of it, we're going to get 3 as well. So when you have an absolute value problem, you need to split it up into 2 problems. 9 minus 2x equals 3, and 9 minus 2x equals negative 3. Now you have two equations that you're going to solve, and in the end you're going to check both your answers. So if I were to solve this, I would get x equals 3, and if I were to solve this, I get x equals 6. If I check my answer, if I plug 3 in here, 9 minus 2 times 3, 9 minus 6 is 3. Yes, that works. If I plug 6 in here, I get 9 minus 2 times 6, or 9 minus 12 is negative 3, but the absolute value of negative 3 is 3, so this answer works. All right, we always want to check our answers in absolute value problems. All right, the last kind of problem I want to go over with you are problems that have fractions in them. All right, so one type might be something like this. Okay? So this is a proportion. When we have two fractions that sit equal to each other, it is a proportion. So one way I can solve that is by cross multiplying. So 4 times g plus 5 equals 3 times 9 minus g. All right, once I have that, then I can distribute, and I have a regular problem that I know how to solve. All right, another way to deal with fractions is to multiply by the least common denominator. So this would work for proportions or any kind of problem with fractions. All right, so here's my problem with fractions. It's not a proportion, so I want to do something else. So one thing I could do is put everything over a common denominator, but when I'm solving our problems with fractions, I like to get rid of the fractions by multiplying by the least common denominator. So the least common denominator of 4, 3, and 6 is 12. So I'm going to multiply the whole equation, both sides, by 12. All right, if I go ahead and multiply everything by 12, here I would get 12x over 4 plus 12x plus 1 over 3 and 12 times 5 over 6. Why is that helpful? Well, this simplifies to be 3x. This simplifies to be 4 times x plus 1. And this simplifies to be 10. All right, that's very helpful because now I just have a very simple equation here. I can combine like terms and solve. All right, so when you have an equation with fractions that is not a proportion, we want to multiply by the least common denominator. All right, try those problem sets and we're going to review them all tomorrow.